Hey, this is Math 6, Unit 7, Lesson 9, Solutions of Inequalities. So we're talking about solutions here. It says, first of all, unknowns on a number line. The number line shows several points, each labeled with a letter. So you have points A, B, C, D, E, and F. We can see, looking at it real quick, that D seems to be at maybe point 0, perhaps there. Okay, looking close to that, means that things over here are probably going to be positive numbers, and things to the left would be negative numbers in terms of values, if there were any values there. It says fill in each blank with a letter so that the inequality statements are true. Now for this part here, it doesn't matter which one you choose, we just want to make a true statement. So we're going to find a letter that is greater than another letter. So essentially, if it's greater than, it's going to be to the right of the other one, right? So F, for example, is going to be greater than any letter over here, and I could choose A if I wanted to, just to make the two extremes there. If I wanted to find that was less than, that I mean it's going to be to the left of that number. Okay, so for example, B is going to be less than anything over here. So B is less than C, it's less than D, less than E, less than F. So you can just pick one and write that letter down. Again, many different answers you can come up with here for this one, which is really what the next question says. It says that Jada says that she found 3 different ways to complete the first question. Do you think that this is possible? Okay, are there different ways of saying that one letter is greater than another? Well, let's think of this one. Let's look at this F one. See, F, we already know, is greater than A, right? But it's also greater than B. F is also greater than C, F is also greater than D, and F is also greater than E. So there were 5 different ways just to do this first one. So when Jada says that she found 3 different ways to complete the first question, do you think that's possible? I would say it's most likely possible, right? There are lots of ways you could organize that, and on your own, you might have thought of your own unique way of doing that already. It says list a possible value for each letter on the number line based on its location. And again, this is a possible, so your answer could be different than what I have. What I looked at, I said, well, if this is 0, let's pretend this is at -1, okay, which would mean that this becomes -2, and that becomes like -3. So I'm doing like kind of half a centimeter space. I kind of went like this, kind of tabbed it out there to say, well, if that's -3, 4, 5, 6, 7, -8 there. And if I did the same distance, I'd put one here, there, and then one probably in between and there. Hard to say. So 1, 2, 3, 4, 5. So maybe I label it like that, and that's kind of what I come up with there. Again, it's just an approximation of what is a possible value for each letter on the number line based on its location. So up to you there, as long as it makes sense, and again that this is a greater negative number value there, and then we have positives over here, you're going to be okay. And D, of course, is already 0. Okay. For the next activity, we have this little chart here that says that Priya finds these height requirements for some of the rides at the amusement park. To ride the high bounce, you have to be between 55 and 72 inches tall. Be between them. To do the climb-a-thon, you have to be under 60, so below 60. And the twirler coaster, 58 inches is a minimum, which means you have to be 58 and up in order to ride that ride. And this is the real world, because if you go to an amusement park, like I often go to Disneyland with my family, plus my son works there too, so that makes a lot of fun. These are real things. So when you're there with a little small child, you know, you want to find out if you're tall enough to ride the ride you want to go on. So this is real world here for those of you getting ready to go on vacation at some point. So let's take a look at the next part. It says write an inequality for each of the 3 height requirements and use H for the unknown height. Then represent each height requirement on a number line. So for the first part, it told us that for the high bounce, you had to be between 55 and 72 inches tall, which means that the height had to be greater than 55, but the height also had to be less than 72, right? So that's what was happening on that one there. Now this one we actually have almost enough lines. I notice here. I did it like this. I said if that's 55, I do 56, 57, 58, 59, 60, 61, 2, 3, 4, 65, 66, 7, 8, 9, 70, 71, and I just went ahead and added one more here to have a 72. So I know that it said you have to be between. Now when it said between to me does not include that actual value. So I would actually make an open circle on 55 and an open circle on 77, and then I would highlight that space between. Let me use a highlighter to help us see a little better. So an open circle, and then any value in between would work for the high bounds. Right? Because it's between. It didn't say it could be 55, it said in between. For the climathon said under 60 inches tall. So it said under 60 inches. So we want the height to be less than 60 inches. Okay? So again, we'll take a look here and we could put this at, we can maybe count by 0 and do 0, 10, 20, 30, 40, 50, and 60. And so we can't have anybody under 0 inches. So we know the height has to be less than 60. That means that it can't include 60 again. So we're going to make an open circle at 60, right? And then draw all the way down to here. I could have a close right there at 0. So the height is going to be under 60 pounds, or 60 inches. So 59 is great, 59.9 is great, but 60 is not enough, not good. So for twirler coaster though, it said 58 inches minimum. So 58 inches minimum. So you have to be at least 58 at the minimum or more. So the height is going to be greater than, right, or in our case here 58, or height is going to be equal to 58. Or if you recall from our last lesson, we could say this could be the height can be greater than or equal to 58. So you can plot a point out here and you could say, in this case here, 58, put it wherever you want, and we would do a closed circle because we're going to include 58, and it's going to be any value greater than that. And so we could just draw an arrow that way. Now I would imagine in the real world there'd be a limit there. You probably couldn't be 3,000 inches tall and still ride the ride. But for now we can leave it like that at 58 and we're good to go. Alright. Number 2. It says Han's cousin is 55 inches tall. Han doesn't think she's tall enough to ride the high bounce, but Kieran believes that she is tall enough. Do you agree with Han or Kieran? Or Karan? So 55 inches tall. So can they ride the high bounce ride? Well, the high bounce is here, and he says that he's actually 55 inches tall. Okay? So he's 55 inches tall, and that's a good question. Can they ride the ride or not? It's a question where you might answer with maybe. Okay? Because all the ride said was that you had to be between 55 and 72. Right? It wasn't clear. To me, it wasn't clear, not clear if 55 was okay. Like it didn't say it included 55. I'm not sure, it just had to be between. It didn't say 55 inches to 72 inches, it just said in between. So it might mean that the cousin can't ride it because he's exactly 55. Maybe if he was 55.1 it'd be okay. But it's hard to say. We really can't be sure whether it's right or wrong. You just have to have a good little conversation about it. What do you think? Right? I think the words between make me think probably not. That's what at least we drew in our graph there. It says Priya can ride the climathon, but she cannot ride the high bounce or the twirler coaster. Which, if any of the following, could be Priya's height? And explain. So she's okay on this one, right? Which one can she do this one, but not that and not that? So what do we know? If she can do this one, then she has to be less than, so Priya is going to be less than 60 inches. Okay? So we know that for sure, and since she can do that one. But since she cannot do the other rides, right? We know that in this case here, the other ones, it's more than 50, 60, so the twirl coaster doesn't help us too much here. But let's take a look. If she's 59 inches would be here. 59 is going to be okay. 59 in this case would be somewhere around here. That's going to be okay. But 59 over here would be okay. And what we said was these should be no's. So because those are yeses, that's not going to work. 53 inches, we can see that yes, it's still okay here, 53. But we only want it okay there. 53 is over there, doesn't work. And 53 is down here somewhere, doesn't work. So in this case, the only one 53 that would work is the climathon. That makes sense for that one there. And now let's take a look at, oh, went too low. Take a look at the 56-inch one. 56 inches, 56 is going to be here, which means it works. 56 works here, and 56 does not work there. But because it works here and here, that's going to be a no. Because we want to know where she could only ride the climathon, and the only value that only works for that one ride is 53 inches. The other ones you could get on something else if you chose to, generally the high bounce. It says Jada is 56 inches tall. Which rides can she go on? So 56, you could take a look here. 56 would be okay there. 56 would be okay here. 56 would not be okay there. So we know she could ride on the high bounce and she could ride on the climb-a-thon. Okay, just abbreviating that for time. It says Kieran is 60 inches tall. Which rides can he go on? Well, 60 is going to be okay. There's 60. 60 here, remember, it doesn't count. You can't do it. It was under 60. So that's not okay there. But 60 over here would be okay. So for Kieran, he could definitely do the high bounce and he could do the twirl-o coaster. The inequalities, h is less than 75 and h is greater than 64, represent the height restrictions in inches of another ride. Write 3 values that are solutions to both of these inequalities. And that's what we've been talking about. Solutions are numbers that fit in the graph. They fit on that line. So you can think of it this way. If my line or graph looked like this, and I had h was less than 75, so here's 75, and h is greater than 64, and I have all these values in between, because it's just a less than and not an equal to, then any number in between 64 and 75 is going to be something that would be a solution. So I could pick 66, 68, I could pick 70, 72, I could even pick a fraction technically, right? I could do 73.5. Those would all be possible solutions to these two inequalities right there. Okay, let's take a look at your summary, and then we'll wrap it up here. So your summary gives you some more examples here. It says, let's say a movie ticket costs less than $10. If C represents the cost of a movie ticket, we could use C is less than -10 to express what we know about the cost of a ticket. Any value of C that makes the inequality true is called a solution to the inequality. So if it's true, it's a solution, and that's what we're looking for there. For example, 5 is a solution because why? 5 is less than 10, so it's a solution. 12 is not a solution because 12 is not actually less than 10. It doesn't work. Okay? Sometimes though, if the solution situation involves more than one boundary limit, we'll need more than one equality to express it. Right? So we could say we knew it rained for more than 10 minutes but less than 30. So sometimes you can use two different inequalities to show what you're talking about there. And in this case, because we're looking for times per minute, we're going to have something in between. And so you can then graph those by combining those together to say, well, it needs to be more than 10, but it needs to be less than 30. And that's what we're looking at there. So visually you can show how those two things go together and form one equation there if both of these need to be true. So more than 10, less than 30, and that's what we have there. So let's pause, let you work on your homework. We'll come back and check it together in just a few minutes. Hey, this is Math 6, Unit 7, Lesson 9, homework for solutions of inequalities. It selects all the numbers that are solutions to the inequality k is greater than 5. So what we're talking about here is if I had this as a number line here, and I had 5 right there as a number, and maybe zeros over here, we're saying we want to find anything that fits this, this graph, where it's greater than 5, not equal to, but any number greater than 5 going this way forever and ever and ever. So when I look at a number like 4, 4 is over here, that's not going to work. 5 is not included in the solution set. Remember, it's not filled in, so we wouldn't include that. It has to be bigger. 5.1 would be good. Oh, look, there it is. 6, that's going to work. Great. 5.2, which is right here, that's great. 5.01, that's bigger. That's going to work. That's okay, right? And 0.5, that's over here, 0.5. That's not going to work, right? So taking a look there, you want anything greater than 5 is going to work for us there. So there are 3 solutions to that one right there. So make sure you circle the right ones. Draw a number line, and there it is, already drawn. That's it. Number 2. A sign on the road says speed limit 60 miles per hour. So let S be the speed of the car. Write an inequality that matches the information on the sign. So for the speed of the car, can you go 59? Yes, right? The limit means that's the most you can go. Can you go 61? No. Can you go 60? Yeah, that's the limit. That's the most you could go. So we could say the speed needs to be less than 60, or we can also say the speed can be equal to 60. And again, as we've talked about here, you might say the speed can be less than or equal to 60. Again, that's if your teachers have shown you that and talked about that like we have here in our videos here. But again, that's probably 7th grade, not 6th grade. Draw a number line to represent the solutions to the inequality. So solutions mean the things that would work for this inequality. So for our solution, we could say, here's our number line, and we can write 60 right over here. I could even include the number 0 because you're not going to go negative. And in our case here, we would say that all values, including 60, between 0 and 60, are going to be okay. So between 0 and 60, those values are all going to be solutions in inequality. Even 0 miles per hour is less than 60 miles per hour, isn't it? Okay, that's your limit. That's how the speed limit works. So speed limit allows you to do 60. You can't go more. That's the maximum. One day in Boston, Massachusetts, the high temperature was 60 degrees Fahrenheit and the low was 52 degrees. Write one or more inequalities to describe the temperature T that are between the high and low temperature. Okay, so you can do one or more. We could say that the temperature is going to be, at the low temperature 52, the temperature is greater than 52 degrees. But we can also say the temperature was less than 60 degrees. So you could write that as 2 different equations like that, or inequalities like that. We could also recognize that the temperature, if you put it in the middle, is going to be between what? It's going to be between 52 and 60. So the temperature is going to be more than 52, but it's going to be less than 60. And that's how you could combine that into one inequality if you chose to. When I want to show those as possible as a number line, then I draw it like so. And we put 52 right here, and I could put 60 over there. Okay. And because I'm not saying it can be equal to, I'm saying that it is, we want temperatures that are between. Oh, actually, I want to go, hard to say. Temperature was 60. No, yeah, we want between. So we want to do ones that are between. So because we're doing between, we're not doing the ones that actually are. A little bit like that one ride we looked at. So we'd probably do open circle, and then all the points in between. So not including the low and the high, but everything in between the low and the high. All right, number 4 is a review question. So we can rewrite this without the absolute value. This is really -5 is less than the absolute value of -5 is 5. So is 5 greater than -5? That is true. Over here, the absolute value of -6 is 6. Is 6 less than -5? That is going to be false. Here, again, absolute value of -6 is 6. Is 6 less than 3? No, that's false. And over here, we have 4 less than the absolute value of -7 is 7. Is that true or false? That is true. And for E, we have -7 is less than absolute value -8. It's on the next page, I know. So this becomes 7 is less than 8. Is that true? That is true as well. Okay, let's flip the page, take a look at number 5, get another review. Number 5, match each equation to its solution. So what number can you do to the 4th power to get to 81? All right, let's look at the 2 first of all. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. All right, not working so far. So if I did 2 to the 4 is 16, there's 8, there's 3, 2 to the 5th, 16 times 2 is 32. So this one works well for the 2. Right there. All right. So how about the 3? Well, 3 times, my choices are to second squared or fourth. 3 squared is 9. Doesn't match those. 3 to the 3rd power is 9 times 3, which is 27. No. 27 times 3 is 81. So that needs to match the first one. Left with 2 more here. We have 4. 4 times 4, which is 4 squared, is 16. None of those. 16 times 4 is 64. That matches that one. There's 3 4s, so 3 there. We're left with 10 squared, 10 times 10, which is 100, and that's that one. The last one, a review from Unit 3, way back when. The price of a cell phone is usually $250. Elena's mom buys one for $150. What percentage of the usual price did she pay? So what did she pay? She paid $150 out of $250 is what she paid. So what is that as a percentage? Well, she paid $150 out of $250. In this case here, we could reduce this if we wanted to. This becomes 15 over 25, right? 15 out of 25 there. Now 15 out of 25 would mean that I'm going to do some division. So 15 divided by 25, and 15, whoops, yeah. That's right. Oops. Been a long day. 15, 25. So sorry. I'm like, what am I doing? That one goes inside. So how many 25s are in 1? 0. 25s in 5. 0. Put a decimal point there. 25s in 150. We would say there are 6 of those, right? Right. So, yep, 6 of them there. So we have 6, which becomes 60. So we have 0.60, but as a percentage, we multiply that, move the decimal over 2 spaces, so you end up with 60%. Okay, so 60% for the first one. For the second one, it says Elena's dad buys another type of cell phone that usually sells for $250. He pays 75% of the usual price. How much did he pay? So he paid 75%, 75% of $250. Okay, so we can go 0.75 times 250 to figure out what that's going to be. And so 250 times 0.75, we have 0, 5, 2, 10, 11, 12, and 0, 5, 3, 14 plus 3 is 17. And we bring those down and add them up. In 2 decimals, we have 187.50 is how much he paid for that cell phone. All right, that's it for today. Have a great day, and we will see you next time.